So today we're going to look at why do we have the factored form. We've looked at the vertex form, and we know that the vertex form is easy to find the vertex, axis of symmetry, you can draw using the pattern. It's easy, right? So we have the vertex form, and it's easy. And we looked at the standard form, which is pretty much useless, right? I only can find the y-intercept from it and nothing else. Now, why do I need a third form? What is the factored form good for? Okay, we've been taking the standard form and then we've been factoring. So why am I doing this? So if you look at this, these are two different equations, right? And they're two different examples. What do we call this form? Factored, because you have the brackets, right? So the one that you have, the one that looks, this doesn't like me. The one that's like this is an R. Where you have two brackets, right? X minus something or plus, and then X minus or plus something else, and then with a number in front, that number could be 1, -1, +7, whatever that number is, right? The A value. We call this the factored form. So far we have looked at the three vertex form, which looks like this. Right, the vertex. We've looked at the standard form, which looks like this. And now we're going to look at the factored form, which is going to look like this. Okay, so they can represent the same equation, but with different looks. Okay, so if you have something that looks like this, we know it's the factored form. So I took this and I graphed it in Desmos or whatever graphing calculator we have, and this is the graph that I got. It's asking you to list all the key features of the graph. So what are your zeros? X equals -2. And, okay? Now, what is your y-intercept? 2. Y equal to, no? Y equal 2. How about your vertex? Where is your vertex? Yeah, it looks like it's at -1.5 and about -1/4, -0.25. Where would your axis of symmetry be? And then your optimal value? Negative, and it's a min or max? It's a min. I said I missed this. You missed what? Now, let's look at the x-intercepts here. Or the zeros, where are they? And 1. Where is your y-intercept? And what is your vertex? Yeah. That's an 8. And what is your axis of symmetry? And what's your y-intercept? The optimal value. Max or min? Good. Now, if you look at your key features that we just listed, did you guys finish copying the key features? I want you to look at the key features, and I want you to look at the equation and see if there is anything common between the key features and the equation. The zeros. What's with the zeros? They're similar. So if you look at the zeros here, they're -2 and -1. In the equation, what are they though? +2 and +1. How about the zeros here? What are they? -3 and 1. In the equation, it's +3 and -1. So they're opposite. So what does the factor form give me? It gives me the zeros. Why are they opposite? If you guys look back here, in the equation, it's a negative. So what happened is, if I have already a negative and I put a negative, what does that make? I have a negative, I put a negative, what does that make? So that's why it's x plus 2, x plus 1. Because technically, in the equation, the s is minus r, x minus s. So the r and the s, they represent your zeros. And I have minus minus 2, which makes a positive 2. Minus minus 1, which makes a positive 1. So your zeros, you can get them from the factored form. So if it's already in factored form, you can tell me what my zeros are by just looking at the equation and giving me the opposite sign. Okay? So let's write this note. And factored form has the equation y equal
zeros, or what else do we call them? And I asked you to find the zeros for me. Here's what you're going to do. Okay, so you're going to take this and you're going to set it equal to 0 because you're finding the zeros. Then you're going to solve for x. So you're going to bring the -2 over. What does it become? And this is one of the answers. Then you're going to take your second bracket and also equal it to 0. Bring it over. What does it become? And this is your second 0. So your two zeros are 2 and -1. So to find the 0, you just have to set each bracket equal to 0 and solve for it. This is what this is saying. Yeah.
Sorry, I'm a little lost. So, what do I have to do?
So, this is your equation, right? It's in factored form.
Yeah.
So you take one of the bracket and you set it equal to 0. Because I'm looking for the zeros.
So replace, for example, the full-on x minus...
No. You're just literally, you're doing this. You're going to do x minus 2 equals 0. And then you're going to do x plus 1 equals 0. So you're going to just take them separately. You're not replacing anything. You're just taking this separately, make it equal to 0. You're going to take this separately, make it equal to 0. So you can find, I'm going to erase this, so you can find your two you can find your 2 zeros, which is going to end up being here and here. You're solving for these points. And the way we're solving for these points is we're setting each bracket equal to 0 and solving. Okay? It has to be in factored form for you to be able to do that. Does that make sense? Yes. Because the question here asked me for something else. You need the top? Okay? So, if it's in factored form, you can find the zeros. If it's in vertex form, you can find the vertex. If it's in standard form, you can find the y-intercept. So the three forms are used for a reason. One is to find the vertex. One is to find the zeros. And the third one is to find the y-intercept. Can I? Now, we learned that if I want to go from standard form to factored form, what do I do? Expand. So that's, you do FOIL, right? Right. Now, what if, no, the other way around. I asked the question, if I want to go from standard to factored, what do? We factor. Okay? Now, if you want to answer this question, you want to go from factored form to standard form, then you expand. Did I lose you guys? How do I expand this? What do I have to do? FOIL. That's right. So y equal